All right, taking a look at our calendar. Today is October the 27th. This is a change from what I gave you on the syllabus on the first day of the semester. What it used to say was today we were going to do lesson 19 in its entirety, and we were going to start lesson 20. I decided, one of my colleagues and I decided yesterday that 19 is a very long and important lesson, long enough to warrant an entire class. And so what we're going to do is slightly change the plan from what I gave you on the first day. Today is all 19. We'll have plenty to talk about today for lesson 19. As scheduled, we've got our quest coming up. This is not a change. On Thursday coming up, we'll start class with our review, like 25 minutes or so, just individually, and I'll answer questions just like we have in the past. We then take our quest. That's all of Thursday. A week from today is advising day. That's Tuesday, November 3rd. You will see that November 3rd is not on our calendar. There are no day classes on November 3rd. Okay, so after our quest, next time we'll be meeting is Thursday, November 5th, and then we will do all of 20. That's the thing we were going to start today, but we just pushed it back a class. Okay, so next time we'll do 20 and 21. Both of them are kind of shorter. I think we'll be okay doing both in one day. The quest, speaking of the quest is on, just scroll a little bit here. So we're looking for quest 3, which is right here, and the material covered is 14 through 18. Notice that 18, today we're doing 19. 18 is what we did last time. So none of what we are doing right now is on the coming quest. You've seen everything that you're going to see for Thursday's quest. We're moving on to new stuff. This will be on the next quest after. Okay. In terms of this coming quest, things that are allowed, you can use the perfect powers sheet. That's the reference sheet. It says here key formulas. This is not something I wrote, but Caitlin wrote this for her class. I didn't realize until just this moment right now that she's letting her students use that key formula sheet. It was a separate handout I gave you guys a few classes ago. And I'm nothing if not a lemming, so let's say that you guys can use this key formulas sheet too. All right, everybody know what I'm talking about? Yes, and then separately, one page, front and back of your own notes. So 3 pieces of paper you're going to bring in. That's the one right there. Carrie's got it. Everybody see it? It's just one side of one page. It's got a few boxes on it with a bunch of our formulas. Okay, so you bring in 2 pages that I gave you, 1 page of your own creation. What you are not allowed, I think I mentioned this before, but it bears repeating, you are not going to be using your calculator on this coming quest. I think it's the only quest or test where it's just non-calculator, but don't bother bringing it, you won't use it, okay? Any questions on the quest? Either what's on it or when it is or what resources you have or don't have? Yes. Thank you. All right, I think that is that. So on page 41, we'll start up here at the top. In this lesson, we factor out the GCF and begin factoring trinomials. Just a heads up, this demo is long. I'm actually going to go off schedule even today, more than I've said already. We're going to do part of this demo, and then you're going to do some of the activity, and then we're going to come back together and do the rest of the demo, and then you're going to go back and do the rest of the activity. So we're going to be kind of all over the place today, but I think this is a better plan than what I had handed out in this packet. So number 1 says multiply these 2 things. Go ahead and do that, please. Fill in the blank by multiplying. Okay, so when we distribute, what do we get for the first piece? 21x to the second. Make sure you have an x squared. It's not. Make sure you have that x squared. It's not 21x. It's 21x squared. Yes. And then the second part is negative 15x. Okay, then I have this word factor. It is quite possible you have seen that in another math class. It's possible you've never seen it. But I'm asking you to factor 21x squared minus 15x, which is exactly the thing you just wrote down. It's up here in orange, yeah? Any guesses on what the answer is, even if you don't quite know what that word factor means? That's it. It's just the same thing that you did, but the other direction. We have no problem distributing something, multiplication over addition or subtraction. That's an old and familiar skill. What might not be so familiar, or might not be familiar at all, is going the other direction. thinking about 21x squared minus 15x as being something on the outside of parentheses. This is the harder direction, and that's what we're getting into right now, okay? And turning addition or subtraction into multiplication, because that is fundamentally what this is, that is what we mean by factor. And in fact, you've actually seen the word factor just in a numerical sense. Like if I ask you, for example, to factor the number 10, 5 times 2. You turned 10 into multiplication, yes? And we say that 5 and 2 are the factors of 10. So you've seen the word factor in another context. It still means turn into multiplication. Factor means turn into multiplication. Up there for 5 times 2, it's just two numbers. Down here we've got expressions with x's, but the word factor still means turn into multiplication. Okay, we started talking about the box last class. We're going to continue using it to our advantage today. Number 2 says we're going to multiply 4x squared y cubed by this whole big thing here, and we're going to use this box. Now I filled in a lot of this box for you already, but notice on the left-hand side, 4x squared y cubed, and on the top are the 3 terms in this other expression here. Negative 3y squared is above the first box, minus 7x squared is above the second box, and then plus 2xy, okay? And what we saw with our boxes last class was that inside of each of these little rectangles, we're supposed to put the area of that rectangle. And if I want to find the area of this rectangle, what calculation do I need to do? Everybody see it? We're multiplying those two things together because area of a rectangle is just width times length. And so that's what we're putting in there. So let's do that one together, and then you'll fill in the rest. 4 times negative 3, that's a negative 12. X to the second, y to the fifth is good. Go ahead and take a moment and fill in the other 2 boxes. Again, we're looking for areas of those little rectangles. Okay, next box, what do we get here? There's a 28, x to the 4, right? 2 plus 2, and y to the third. And then there's something that I missed. And I actually did miss it. What did I miss? It's negative. That subtract is really a negative 7. Probably in retrospect, I should have put that subtraction sign right in front of the 7 so I wouldn't miss it. And then in the last box, what do we get there? 8 y to the 4. Good. So what that means, it's written down here, is that if we multiply 4x squared times all this stuff in the parentheses, it's exactly what we did in the box. All we're doing is writing the things that are in those little rectangles. Negative 12x squared y to the 5th is the first guy. Subtract 28x 4y3 plus 8x cubed y to the 4. Questions on that? That's the easy direction. That's multiplication. Now we're going the hard direction. Suppose we want to go the other direction, that is to take our final answer, which was this guy. Yes, it's just that guy, and factor it. I'm going to call it unbox, but the official word is factor it, right? Somebody multiplied 2 things together and got this big long expression, and we want to know what they multiplied together. Okay, well this one's easy because the answer is right here on the board. I mean, like the goal is to get over to that, yeah? But we're not going to have it in front of us in general. So we take the last thing and try to get to the factors. So the idea here is to find the greatest common factor. We'll abbreviate that GCF, greatest common factor. Of all the terms in this yellow highlighted thing, there are 1, 2, 3 terms separated by addition and subtraction. Some lucky people can do this just by looking at the terms. So you might be able to look at negative 12x squared y to the 5th, and negative that, and positive that, and just decide what is in all of them. What do they have in common, and what's the greatest thing that they have in common? But in case you are not one of those lucky people, there is a process that we're going to look at all the details of. You don't need to follow the process. You just need to get to the end, either by this process or some other one. Let's give it a shot. First, we're going to look at the coefficients. This is a word we have not used in this class. It just means the numbers in front of the x's and the y's. So I'll highlight in blue here coefficients. Negative 12, negative 28, positive 8. Okay, and what we're looking for is the greatest common factor of those 3 numbers. What's the biggest number that goes evenly into negative 12, negative 28, and positive 8? 4. It's 4. Everybody see that? Okay, so We see that 4 is the GCF, since 4 is the largest number that divides all three of those guys. So now we're going to take the original expression, it's still highlighted, and we're going to write out all of the factors, including the 4 that we established above. So that negative 12 is really 4 times negative 3, agree? And the next thing was a negative 28, which is 4 times negative 7, so that's there. And the last one was 8, which is 4 times 2. So all I've done is changed the numbers so that the 4 that they have in common is readily visible to us. So far, so good. That's the number part. The harder part is the variables. Again, this is a lot of details that I do not need to see, but just stay with me for a little bit, and maybe you'll develop some shortcuts on your own with practice. X squared y to the 5th. I'm going to ask you to just write that out. X squared y to the 5th. 2 x's written next to each other, 5 y's all laid out next to each other, okay? Same thing, x to the 4th y cubed, right there. X cubed y to the 4, right there. So we just list them all out. It takes some time. Like I said, there are shortcuts that you might develop on your own, but this is the method that I'm presenting to make sure that everybody gets it, even if it takes a little bit of time. Next thing we're going to do is we are going to circle those factors that are in common to all 3 terms. 3 terms are separated by the subtraction sign and the plus sign. So, looking at the x's, how many x's do you have in the first term? 2. Second term? 4 of them there, right? And the last term? It's 3. We're trying to take out as many as we can, but you can only take what you have in all 3. What's the most that they have in common? Is 2 x's. You buy it? So what I'm going to do is circle in green those 2 x's right there. Just the first 2 x's in the next guy. I can't take out any more. It's got a few x's left over, but all I can do is take out what they all have. And so I'm going to circle exactly the same thing in all 3. In this case, it's x squared. I'm playing the same game with the y's. How many y's in the first one? 5 of them there. The next one is 3 and then 4. You want as much as you can, but only as much as they all have. How many? 3 is it. I'll circle here. I'm going to circle in all, but that's the one that kind of dictates this, right? That's the one that has the fewest y's. So we're circling 3 y's there. So I'm circling 3 y's here and also 3 y's over here. Okay. I am looking at what I've got here and I'm not thrilled with it. I need to erase something. Yep, that's good. My purple circles are no good because in purple I circled everything. I'm not thinking about where we were going. What I intended to do was circle only the stuff that's in common. And so what number do all 3 of these things have in common is the 4. So I just want to circle the 4. Okay, I'm happy with that now. And so the thing that all 3 of them have in common is what was circled in all 3 cases. And what was circled in all 3 cases was a 4, as well as a couple of x's, as well as 3 y's. And you guys buy that that's exactly what we circled 3 times. 4, x squared, y cubed. And so by virtue of being in all of them, and being the biggest thing that was in all of them, we have found the greatest common factor. It is exactly what we circled all 3 times, 4x squared, y cubed. And so we know that if we're going to factor the original problem, this is highlighted thing up here at the top, we know that the thing that's in common is this 4x squared y cubed. So it's going to be in the front. And then there's going to be some parentheses, which we still have to fill in. But that's the thing they have in common. That's what somebody distributed through. So the last step is just to fill in what they didn't have in common. And the beautiful thing about laying this all out and then circling is that the stuff that we didn't circle is exactly what goes in these parentheses here. So what didn't we circle in this first term? You see that? Negative 3y squared? Well, that's exactly what goes right here, negative 3y squared. And you should totally buy that because when we distribute, I mean, there's going to be more stuff in here in a second, but when we distribute, we know we're doing 4x squared y cubed times this guy, right? Well, the 4x squared y cubed is what we circled, and then this is what we didn't circle. And so when we smush them together by multiplying, we're going to get exactly the entire first term. And so then continuing on, what was missing, what wasn't circled in this middle guy? Negative 7x squared. And then in the last guy, 2xy. That's it. Okay, so how does that compare to what we knew the answer was? Because we did the easier version of this problem to start. 4x squared y cubed, and then a bunch of stuff. How does that compare? Same. That's the idea, right? Okay, so I think we've got that. As we said, factor means to turn into a product. It's also possible to do this with a box. I'm not going to do the whole thing with the box. I just want to jump into the activities so you can start practicing right away. But I just want to see if we can get to the place where we can pull out the greatest common factor here. Okay, the beginning is the same process. Negative 12x squared y to the fifth. All of these things are the original problem. I'll highlight it again. It's the same thing we highlighted up above. So those just go 3 separate terms into our box. And then we'll just look at the numbers, 12, 28, and 8. What's the thing that the biggest thing they have in common? It's still 4. So we're just going to put the 4 out there by inspection. And then we're going to look at these x's. Now, we don't have this device of writing them all out. We're just going to look at them. How many x's are in the first guy? There's x squared, so that's 2 x's, right? How many x's in the middle guy? It's 4. And in the last guy, 3. And you want to take out as much as you can, but only what they all have. What's the biggest thing that they all have? Is the x squared. And so there's like a lot of processing involved and very little writing when you get to the final answer. And it's kind of strange because we're looking for the greatest common factor, but which power of x did we pull out? The smallest one. Do we see that? We were looking for the greatest common factor, but for some reason that involves the smallest, the lowest power of x. It kind of makes sense if you think about it, because you want what's in everything. And what's in everything is going to be the smallest power. Looking at the y's, y to the fifth, y cubed, y to the fourth. I want to take as much as I can, but I can only take what I have in all of them. What's y cubed? That's it. That's the GCF. If you like the circle method, do it. If you're comfortable doing this, do it. It doesn't matter to me. You just got to get to the answer. I said I wasn't going to finish, but it's actually not hard to finish. So let's just finish. There was a 4. There's a negative 12 in this first box. I'm supposed to put something up here so that when I multiply the 4 times the something, I get the negative 12. What's the something? That's got to be a negative 3, right? Just kind of working backwards. Skip the x's for a second. I have y cubed. I'm supposed to end up with a y to the fifth. What power do I need up here so that when I multiply the outside stuff, I get y to the fifth? It's got to be 2, right? Because looking at it here, y cubed times y squared, I know that's what I'm supposed to put in the box, and that's exactly y to the fifth. So it's just a thinking backwards type thing. And then finally, the x's. I have x squared out in the front. I'm supposed to end up with x squared in the box. So how many x's am I putting up here at the top? None at all, not even 1. As soon as you put an x there, you're in trouble. You had only x squared in the box, and all of them are out here in the front. So that's it. Okay, let's have you guys try to fill in these last 2. This is tough. Let's see if you can fill in the 2 things that go right above here in the box, and then we'll come back together and then do the activity. Sure. Let's see. I see a 4 on the outside. I'm trying to build it to negative 28. What's the number? Negative 7 is good. Just looking at the x's now. I've got x squared already accounted for, but I'm trying to build an x to the fourth. So how many x's we're missing? X squared. Looking at the y's. Y cubed out there. I only needed y cubed, so how many y's? Not a single one. And then finally this 8, 4 times 2. I'm going to ask you guys to say something additional. Plus 2. Okay. It's positive 2. I'm going to try to stay in good habits myself and insist on writing those signs, even if it's plus, which usually means it's not mandatory. Okay, I have x cubed in the box. I've got x squared already accounted for, so how many x's? Just a single one. Y to the fourth in the box, but only y cubed out there. So a single y over there, which means that our final answer, that is this guy here, is equal to the product of two things. First thing is that GCF in the front, 4x squared y cubed. Big parentheses, go ahead and copy that and fill in the parentheses based on what's in the box. And hopefully we see that this box method gives us exactly the same answer as the writing it all out method and circling, okay? Again, I have no preference which one you do, just get really good at one of these. Okay, so the demo continues, but like I said, we're changing things up a little bit here. This is more text. You can take a look at any of that as you're reading through, but this is all written out, the stuff that we just did. The demo is going to pick up again at number 8, but we're not going to do that right now. Instead, we're going to jump to the activity. So I want you to jump to the activity, which is just a few pages away. Looks like 145. So here's what we're going to do on the activity. The problem that I want you to work on right now is number 1. Goes to this middle of the page. It's got 6 parts in it. Once everybody's finished with number 1, I'm going to call everyone back together, but there are going to be some speed demons who finish faster than some other folks, and that's okay. So 1 is the minimum requirement right now. If you are a speed demon and you finish 1 before I call you back together, written over here on the sideboard tells you where to go. You're going to go to the even more practice 4 through 9, okay? I'll walk around and help, and then we'll come back together. Okay, so back on page 142, we're going to continue on with this demo on number 9. It says, here's one that's tougher. Factor negative 2x cubed plus 8x squared plus 24x. First, we'll factor out the GCF. This will always be the first kind of factoring to try. Try that here and then check your answer below. Okay, so let's give that a shot. Looking in this box that's already filled in for us, we're looking for the GCF, greatest common factor of all 3 terms. What number goes into all 3 numbers? 2 is good. Somebody we haven't heard from yet today. How many x's can I take out of all of them? Just a single one, right? So put a 2x out there. Take a moment to fill in the stuff across the top. Let's see, upstairs, how many x's are we missing? 2 of them, right? Because there's 3 of them and we've got 1 of them pulled out. Am I missing anything else in that first term? Is that negative? Don't forget your signs. Okay, the next one, 2 is supposed to turn into 8, 4, and then x. What am I missing here? Positive. Again, it's really easy to not put them because you've been trained for a long time. You don't have to put positive signs, but we do need plus signs. So we might as well just put them all. And then finally, 2x to turn into 24x is plus 12, positive 12. Okay, so that means that we've got this highlighted thing here. So that's where we started. That was the original problem. And we factored the 2x out in the front. And what's left is what's on the top. So we should all believe this equation here in green. But it turns out that we can factor this guy in the parentheses. How many terms are in this parentheses? It's 3, right? And so 3, you guys know tri is a prefix. It means 3. So that thing in the parentheses here is called a trinomial, something with 3 terms. And factoring trinomials is a different kind of factoring than factoring out the GCF. So we're about to learn this massive new technique. Some of you guys might have seen this in another class. It's okay if you've never seen it before. But I just want to highlight at this moment, even though we're about to develop a second factoring technique, which will solve different kinds of problems, the first kind of factoring to try on every problem is that GCF. That's always the first thing. I'm going to say this again because we're going to learn a few different factoring techniques and we need to know them all. But the first one to try, even after we've got all these techniques, is always take out the greatest common factor. Okay, here we go. We're going to try to factor that thing in the parentheses there. And we're going to use the box, but this is going to be a 2 by 2 box, which will make things much tougher. So here we go. I'm just going to copy the thing in the parentheses so we've got it in front of us here. So I've got a 2x2 box. It's not clear why we should have one of those, but it will be soon enough. I put the x squared term, that's this quadratic term, in the top left box. So negative x squared goes right up there. I'm going to put the constant term, which is just the 12, in the bottom right box. 12, what else did I put besides the 12? Positive sign. Again, I'm going to try to be in good habits and always include those signs, even when it seems like we don't need to. Okay, now we're going to do a quite strange thing in number 10. We multiply the two entries on the diagonal. I've got a little arrow here leading me outside of this box. Negative x squared times positive 12 is negative 12x squared. By the way, just to give us a sense of where this is headed, the goal is to factor. And we know that factor means turn into multiplication. So it turns out that this thing in black, this trinomial here, is equal to some stuff multiplied by some more stuff. And we're after the stuff right now. But it's just a lot more complicated because there's two sets of parentheses involved. Okay, so we've multiplied on the diagonal for some unknown reason. And then we're going to take this quick detour. It says use a box to multiply a plus b times c plus d. So let's do a 2x2 box. So everybody write this in the blank space down at the bottom. So we go a plus b there, c plus d there. And we're just going to multiply, again, recognizing that inside of these little rectangles are supposed to go the area of each rectangle. So for example, what expression represents the area of that rectangle? A times d. So we just put a, d there. Yep, go ahead and fill in the other three. Just carefully line things up. Start with the stuff on the outside. So a plus b and then c plus d. Okay, so presumably we've all got the box filled in correctly here. And now what we're going to do is this really, again, strange thing. We're going to find the product of each diagonal. Two different diagonals we're going to multiply. So let's multiply this way first. And when we multiply this way, we just get a times c times b times d. Yeah? ac times bd. Good. And if I felt like writing this in alphabetical order, it would just be A, B, C, D. Thank you to whoever was singing. We appreciate that. You know, I only learned very late in life that the tune for the alphabet song is the same as Twinkle, Twinkle, Little Star. Okay, other diagonal. Multiply this way, so we get A times D multiplied by B times C. And again, if we're alphabetically inclined, what is this? A, B, C, D. So it's the same, which the first time you see it, it's kind of a surprise. So it turns out whenever you use a box to multiply a binomial, that's this two-term A plus B thing, by another binomial, that's this two-term C plus D thing, if you use the box and you multiply the diagonals, you would get exactly the same thing, regardless of what the original things were, right? A, B, C, and D, there's generic. They could be anything. Could be x minus 5. Could be x squared plus 3. Could be anything. The product of the diagonals of this 2x2 box are always the same. That's important to us. We have multiplied along this one diagonal and gotten negative 12x squared. We've got some blanks in the box. Whatever those blanks turn out to be, what do we have to get when we multiply those two blanks together? Has to be negative 12x squared. So we just proved, right? So we are seeking to fill things in the box and those blanks that multiply together to get negative 12x squared. So that's the next step. That's the motivation for what we're about to do. Two things in the blanks have to multiply to negative 12x squared. Here we go. We're going to list all the pairs of factors of negative 12x squared, insisting that each factor have an x in it. So I've listed these guys out already here for you. But for example, one thing you could multiply to get negative 12x squared is 1x times negative 12x. Agree? And there's another thing that will multiply to give you negative 12x squared. We are just looking at all the ways to get negative 12x squared. There's not too many, right? Negative 12 could come from 1 and negative 12, 2 and negative 6, 3 and negative 4, 4, negative 3, 6, negative 2, 12, negative 1. That's a complete list. Again, just insisting that each of them has an x. Okay, so any of these 6 pairs of things could go in the box, and regardless of which one we pick, what would we get when we multiplied? We get negative 12x squared. That's how we built these things, right? Okay, but you don't get to just arbitrarily pick one. Only one of these guys is the right thing to put in those boxes. So the last piece of this puzzle, it's going to seem a little strange, so we're going to add these two things. And that's kind of a weird thing to do because they came thinking about multiplication, right? 4x times negative 3x, multiply, give you negative 12x squared. But now we're going to do something completely unrelated, at least on the surface, and we're going to add them. So 1x plus negative 12x is negative 11x. What's the next row? Add these two. Negative 4x. Go ahead and fill in the next 4, please. Just adding straight across for some to be determined reason. Okay, we have our sums, the ones that we didn't say out loud yet, negative x, positive 4x, and positive 11x. Questions on those? Okay, so far in the box, we have used the negative x squared and we have used the 12, both of which came from the original problem. What have we not used from the original problem? Is this plus 4x here in the middle. We have not thought about it yet. You see it over there in our list of sums? Now is the time to use this plus 4x. So what we're going to do is we're going to grab the answer over here that was this plus 4x and recognize that it came from 6x and negative 2x. And those are the guys that are going to go in those blank boxes, okay? It's the only time this middle 4x comes into play. You got to list all of your factors, add them all up, and hope that you can find one that adds to that middle guy, plus 4x. Notice that negative 4x might be tempting. In fact, if you've got one answer, you're going to get the opposite answer in this list, but only one of them is the right sign. So we got to be really careful about signs. The other thing I'll say, you don't actually need to list every single one of the factors. If you can kind of juggle in your head the idea that we need things that multiply to negative 12x squared and simultaneously add to this 4x, some of you, lucky folks, might be able to just jump to the 6x and the negative 2x. Good for you. That's awesome. Do it. I don't need to see all these listed out. And even if you are listing them, you can just do them one at a time. And as soon as you hit the winner, you can stop. Okay, so we're going to take the 6x and the negative 2x and put them in the blanks in the box. You can put them in either order, but since I've already typed them in this order, why don't we just do them in that order? See them? I'm on number 13 now. So you put 6x in one, you put negative 2x in the other, just like I did here in number 13. Okay. The box is completely filled in. We started with an empty 2x2 box. All 4 of those entries are filled in now. And so the last step is to pull stuff out, put things around the outside. A moment ago, don't copy this, it was something like this, right? A, B, C, and D. Yeah. Well, it's not those in this case. We just got to figure out what they are. So what we're going to do next is factor out the GCF of the first row. Looking in the first row, what letter do they have in common? X. And can I pull out x squared, or is x the best we can do? X is the highest thing that we can pull out, right? And if you see negatives in everything, then I would argue that the negative is part of that greatest common factor. So I would love for us to put a negative x out there in the front. Okay, so we've pulled out the greatest common factor. That's something from earlier today. Now, I chose to do this in the first row, and I'm going to encourage you to just be consistent and as a first step, just pick the first row every single time. But the fact is you could pick the second row and start there, or you could pick the first column or the second column. I'm just going to do this one, but it's arbitrary which one you pick. But once you have started, once you have picked that one row or column and pulled out the GCF, you have no more freedom, no more choices. We just have to fill in the rest of these blanks, and there's just a single correct answer. So let's think about the fact that this negative x squared was supposed to be the product of these two things, yes? So that gives us enough info to fill in what goes on the top here. What do I need to put up there so that it multiplies to give me negative x squared? It's positive x. So we're going to throw an x right there. I'll follow my own convention here. I'll put that plus sign. Okay, let's look at the next guy, this 6x. 6x came from multiplying this thing, which I now know is a positive x, times this unknown thing over here, yeah? What's the thing that goes in the front here? It's a positive 6. So let's fill in a positive 6 plus 6. And last thing, we'll go here. Negative 2x came from multiplying that orange thing times the unknown thing. What is it? 2 or is it negative 2? Positive 2. Good. So let's put a positive 2 out there. Plus 2. Okay. There's actually one of these 4 entries in the box we haven't looked at yet. Which one did we not do? Was that plus 12, right? And we have no freedom. If we've done everything right, it's going to work, but you really should cross your fingers and check to make sure that it works. And if we check, do we see that plus 12 is exactly the product of those two things? Yeah, if it didn't, there's a mistake somewhere. If you do it right, it's going to work out perfectly. Okay, well, I think we're done. Let me copy the original problem one last time. It was negative x squared plus 4x plus 12. Go ahead and copy this in some blank space on your page. And it is equal to the product of two things in parentheses. And we just have to read those things from outside the box. Clicking on the outside on the left, I get negative x plus 6, negative x plus 6. And across the top, what do we get? X plus 2. I'm not going to write a plus x. You don't need that leading positive sign. And that's it. And this is a lot harder than multiplying. Multiplying these two things in the 2x2 box is pretty straightforward. You just multiply, find 4 areas, and then combine like terms in the middle. But factoring, which is what we just did, is a lot harder. Should not be surprised that this is a long process. Probably the longest process of anything we'll do this semester. The last thing for this problem was that the first step we did was to factor out a GCF. These details are written out here with lots of arrows that took me a stunningly long amount of time to draw. You can read it later if you need a reminder of what we did today. So what we just wrote down was this thing. We're on the next page now. But remember from the very beginning, the first thing that we did was factor out this 2x. This was a while ago, so we might not remember that. But that 2x still needs to be in your final answer. So I've got my 2x written down, and then the thing we established up here in green is there. So it's 2x times all the stuff we just got in green. Okay, so that's that. We're going to start the activity in just a second. So let's say this. So some of you guys already have a lot of experience factoring trinomials, and that's great, and you're welcome to use whatever experience you have. I am not requiring you to use a box for any of these problems. That said, so I suspect that some of you guys have shortcuts for things like this, x squared minus x minus 12. It's definitely equal to the product of two things. Raise your hand, don't say out loud, but raise your hand if you think you can just kind of do this one by looking at the numbers. We've got 2, and some people maybe. Lennon, what do you have on this one?
X minus 4 multiplied by.
Okay, so I can assure you, this is the right answer. I can assure you that Lennon did not do the whole 2x2 box thing in his head, going through the process that we just laid out. So he's got some technique, some trick that he has learned, and he is welcome to use that. If you don't have it, then you're using the box. That's all I've got to show you. It turns out that there are some nifty little shortcuts. In this case, we're looking for two things whose product is that and whose sum is I'll put a 1 in there, whose sum is -1. I just need two numbers that multiply to -4 and add to -1. And those are your two numbers, -4, +3. What do they multiply to? Is -12. What do they add to? -1. So why would I show you this entire box thing if all we need is two numbers that multiply to -12 and add to -1? And it's because this whole product sum thing is a great shortcut, but it is entirely out the window if this thing in front of the x squared is anything other than 1. And so if, for example, I gave this problem, I got to think to make this thing up. Let's try 6x squared plus -12 minus 8x minus 8, something like that. The fact that this is no longer a 1x squared, but it is a 6x squared, takes that product sum idea and tosses it out the window. And I don't have any nifty little shortcut for this guy. I used to teach the product sum idea as recently as a year ago, and then would do the 2x2 box for this more complicated one. But I just decided, you know what? I'm going all in on the box. No need to learn a shortcut when you've got this more general method, this 2x2 box idea. So use the box if you have no alternative. If you got a shortcut, you're welcome to use it, but know that we've got harder stuff coming for which I don't know of any shortcut. And I'm going to push us towards the box in that case, okay? All right, so pick up where, let's see, not where you were, but pick up in the activity on number 2, regardless of where you were. So we're moving to the next page here, 145. And you're starting at number 2, and you are just going as far as you possibly can go. Before you jump in with this is a good time to stand up and stretch. We're about halfway through today, and then we'll jump in at number 2. It doesn't